Good morning, ladies and gentlemen. My name is Karel Pertri. I'm the host for your session. Future-proofing fiber networks with AI, sustainability and innovation. Vendors continuously seek to innovate and at the same time leverage their innovation to ease the business case, lower cost, and increase predictability and quality of performance, operation and maintenance of the fiber networks. And the number of challenges is increasing, with sustainability being in the spotlight and artificial intelligence being omnipresent at this conference. During this workshop, we will discuss strategies, methodologies, solution approaches to shape the futures of fiber networks with artificial intelligence, sustainability, and innovations for the next generation technologies. We have therefore gathered 4 experts that will share their views and different aspects of the future of broadband infrastructure. The speakers will present their opening statement, and then we will evolve into a panel discussion. So here at the front, we are ready, and I hope that you're ready too. So let me start with the introduction of the first speaker. The title of the presentation is Key Drivers to Decarbonize FTTH Networks, Strategies for a Sustainable Future. And let me shortly introduce you the first speaker, Theo Lambert. Theo has been the Technical Director for Europe at NetSeed since 2019, overseeing the product strategy for FTTH infrastructure market. As European operators increasingly focus on sustainability, he has played a key role in integrating eco-friendly solutions into NetSeed's portfolio and supporting the decarbonization initiatives across the region. Theo, please take the floor.
Take this one, right? Thank you very much, Carl, for the introduction. Good morning to everyone. So today we will discuss key drivers to decarbonize the fiber infrastructure, notably 3 important messages I would like to share with you toward a strategy for a sustainable future for the FTTH industry. Let me first start with the introduction of who we are and what we do at NetSeed. So NetSeed is a telecom specialist distributor for the broadband infrastructure industry. We are operating in 20 countries across the globe, including 11 in Europe. What differentiates us in the industry is our one-stop shop offering, allowing the infrastructure operator to centralize their sourcing of equipment through a unique partner for the end-to-end infrastructure project. We operate not only in the fiber infrastructure industry, we are also in the AI infrastructure industry as well, and on the wireless segment. So at NetSeed, we have a ESG program in place, and we do focus today in 4 key areas. The first one is driving climate action. The second one is caring for our people. The third one is to provide an eco-design and sustainable offering to the industry, and it's the topic that we will be discussing today. And the last one is acting with integrity every day. We are contributing to 4 out of the 17 United Nations Development Goals, Sustainable Development Goals, and we do strive to tackle global challenges while meeting our stakeholders' expectations in this context. So, Europe's ambition to become the first continent carbon neutral by 2050 impacts all industries. The Green Deal that was signed in 2019 and its regulatory framework impose the investors to invest in sustainable businesses, and the businesses to invest in accountable and responsible companies. And the businesses to act responsibly and accountably in their proper industry. So it is in this context that we are operating today. For instance, operators must balance costs with sustainability. And on the supply chain part, it's important to provide eco-design solution by using, for instance, local sourcing. A recent survey from the Joint Islands for CSR states that up to 80% of telcos' typical Scope 3 carbon footprint comes from the supply chain, which means that there is an important task for the manufacturer and for the suppliers to work on the reduction of the carbon footprint of their product. The Fiber Broadband Association recently stated that previous technologies had a higher carbon impact than the FTTH technology, which is a good sign for our industry, but there is still a way to go to become carbon neutral by 2050. So the question for today is, how can stakeholders contribute to the decarbonization of the FTTH industry? So let's first have a look at the different building blocks of a FTTH passive network. So at the point of presence, also called POP, it's today possible to integrate renewable energy solutions, such as photovoltaic panels on the POP's roof. And it's also possible to have smart ventilation equipment within the POP to reduce the need for special heating and cooling equipment. Consequently, it has a positive impact on the carbon footprint versus previous generation. On the fiber optic cable, manufacturer can today provide reduced diameter for both the fiber and the fiber optic cables, which has an impact on the outer diameter of the cable. And in the case, for instance, of blown fiber optic cables, they can be blown in smaller microduct. Consequently, this has a reduction in terms of polyethylene raw materials that is used for both product categories, and the impact on the carbon emission can be reduced up to 40%. Manholes are also a key element of the underground fiber infrastructure. They can today be manufactured with a rotation molding process, which use a lower temperature at the factory, but also with recycled and recyclable content toward a lower CO2 emission. And the duct, as we mentioned, related to the fiber optic cable, duct can also be manufactured with 100% regrounded HDPE, which means that in the factory there is no longer waste of raw materials, which are commonly called eco-duct on the market. On the cabinet, new generation of cabinet, semi-automatic cabinet using a patch robot are today start to be used in Europe, for instance, and allow the infrastructure operator to reduce his CO2 emission from truck trips. And I will dive into this component next. For at the customer premise side, the FTTH components can be designed using recycled and recyclable components, which is also in favor of more eco-friendly products. So let's jump now to the next message, next lever. So the patch robot, as you can see on the video, it's a system that can be integrated either in an ODF, for instance, inside a POP, or within a cabinet, a street cabinet. It's designed for up to 1,000 fiber connections. And the principle is quite simple. Everything is done remotely, the patching, the testing, the cleaning of the fiber. So what we have done, we made a calculation based on our assumption of the carbon footprint during the use phase of such a cabinet, semi-automatic cabinet, with a traditional cabinet. So for the sake of the exercise, we had to take some assumptions. So based on a churn rate of 5 years, in the case of a traditional cabinet, 300 truck trips per year. And in the case of a patch robot, 1 truck trip every 100 connections, mainly for maintenance purposes. Our calculation, as I mentioned, were based on the use phase only here. And we measured a positive carbon impact around 3,500 kilograms of CO2 equivalent per cabinet per year, which is equivalent to the absorption of the carbon by 175 mature trees per year. So if you do have a project for 1,000, 5,000, or 10,000 cabinets over the next 5 or 10 years, you can easily measure the impact, the positive impact on the carbon footprint on your infrastructure. And the last driver is related to the circular economy. In case of churn, internet service providers must refurbish their set-top boxes, as long as the technology is not obsolete, of course. And this service is already offered in our industry at the global level. Netseed is an active contributor in this area. It consists of different services for set-top boxes, fiber gateways, mobile broadband equipment, various accessories. And the process consists of sorting, cleaning, repairing both plastic and electronic components, but also software update or calibration. As you can see on the presentation, we have 2 examples. One device with scratches, one device with a damage. And by either doing polishing or repairing, we are able to give this equipment a second life. So Netseed is an active contributor in this industry, as I mentioned. So we have in 2024 refurbished 4 million devices around the world. So as a conclusion for today, we have discussed the challenges that our industry is facing, mainly with the Green Deal that was signed in 2019 and which imposed Europe to become carbon neutral by 2050. We understood the impact in our industry, and we have identified 3 immediate levers that are available to the industry to reduce the carbon footprint. The first one is the eco-design building blocks of the FTTH network. The second one is the semi-automatic patch robot cabinet that reduces the CO2 emission from truck trips. And the last one is refurbishing of set-top boxes and other devices toward a circular economy. So as a call to action, we encourage the FTTH stakeholders to review their specification toward sustainable product and solution in order to help us to achieve the net carbon by 2050. So thank you very much. And in case you have any question, feel free to visit our booth. Thank you.
So thank you, Theo, for giving us a glimpse of how decarbonization can be driven in the future. Let me introduce to you the second topic, titled Get Ready for Generative AI, Transformative Power. The speaker is Alistair Wade. Alistair has worked in the data center industry for many years and for high-tech companies in the semiconductor, networking, switching, and infrastructure provider sector. Lately, Alistair works in market development role at Comscope, where he is engaging with social media cloud, colocation, and service provider companies, providing advice on infrastructure development for the next generation of applications and network infrastructure.
Thank you very much for the introduction. Good morning, everyone. It's a pleasure to be here at the conference talking to you today. So hopefully my presentation is going to be a little bit controversial, talking about AI in the fixed network. You know, I was listening to some people talking yesterday on the stage, talking about how the fixed network is done. We have all the endpoint connections. You know, why do we have to change anything? So I want to challenge that thought today and take you with me on that conversation. Just before I go into the first slide talking about what is AI, I just want to remind you about CommScope. Some of you probably know the organization. If you don't, CommScope is an end-to-end solutions provider of fiber infrastructure, passive infrastructure connecting from the central office to the home, and also we have a data center business and an office network building business as well. So we really have a full end-to-end system that you could see at our stand. So firstly, just coming back to the slide deck, I really wanted to talk to you about what AI is, because we hear this term a lot mentioned, but maybe we don't understand what it is. So if you look on the bottom line there, I've got inference AI, and that's something that's been around for a long, long time. So inference AI is, I've given the example here of a Google search on the right-hand side. You type in my name or CommScope, and then Google infers what you might want to know about CommScope or Alistair Waite. So it gives you a number of hits back. And that's been around for some time, certainly in the data center industry, probably since the mid-2000s or 2010s. Then that changed. Then we got generative AI, which has come about in the last 3, 4, 5 years. And that's where AI has really taken off and really pressurized the networks that we're building and we're provisioning today. And generative AI, as the term suggests, is it's taking a request from a human or some machine, and it's generating something brand new. So whether that be a piece of music or a piece of artwork, it's creating something from nothing. I say nothing, but it's the data sets on the left-hand side, the large language models. And so I think that's important that we all have a level setting around what AI means. Inference AI, but then generative AI, creating something new. And the generative AI piece is really what's challenging our business, both in the data center and the fixed network today. It's really pushing the boundary of what we can do and what we have to provide. Just to give you some perspective on how pervasive AI is becoming, if you look at that bar chart, if you look at the blue bars, those are just what I call traditional CPU-based servers. Then if you look across the x-axis out to the right-hand side, you look out to 2028, and you can see how much those bars change from a blue color to a green color. And those are AI-based servers. So certainly by this year and next year, there will be more AI-enabled, probably GPU-enabled server shipping than there were traditional server shipping. And the reason for that is those GPUs are really the workhorse that's behind the generative AI boom. So suddenly we have a lot of horsepower in silicon that can both generate and consume huge amounts of data, the likes of which we haven't really seen before, certainly not in production networks. So the impact of AI, you can't open your web browser, your newspaper, wherever you get your news from, and there's always some article on AI at the moment. And we know that countries are very, very concerned about AI and generative AI because it can be used for good. So we can solve societal issues, but also it can be used for bad. Okay, so criminals, some nefarious people are using AI potentially to undertake tasks that maybe society doesn't want to have, or maybe third-party players as well. So I wanted to touch on legislation that's out there at the moment. So on the left-hand side, I've got the EU AI Act, 2024-1689. that act is really focused on the impact of AI. Okay, it doesn't actually say, well, if you have generative AI in the European Union, it must be sat in Austria or it must be sat in France. It doesn't go to that level. And then on the right-hand side, we have the US Cloud Act. So if a US court subpoenas some of the cloud service providers to provide data that's held in their cloud, they have to do that by law. They have to comply. And clearly at the moment, we have certain sensitivities, social, political sensitivities at the moment. Countries, governments, and organizations are becoming very concerned about taking their data and placing that data into a cloud that could potentially, or into an AI instance in the cloud, that could potentially be used in the US, or the information could be taken to the US. So what we're seeing now is that there's a change of dynamic. Many European governments are looking towards trusted partners to develop AI data centers and AI networks for them. And in many instances, what you'll see is those organizations turning to the large service providers that they have incumbent currently in their countries. They're large enough to be able to build these type of architectures. They're established, and they're typically headquartered within the country that they're operating. So in those instances, the service providers can offer service to the host government, knowing that the data will be held within national boundaries. And for the first time, that's really becoming very, very important. So there's number one impact that we're seeing on service providers being asked to provide sovereign AI networks. Talking about service providers, and again, I listened to a few conversations yesterday, and much of the focus around AI was on the two left-hand bubbles. So it was around OSS and BSS enhancement, automating routine tasks, or the middle bubble around improved customer experience. So how can we use AI agents to interact with our customers on the phone or through billing or some other types of services? But on the right-hand side, and this is where I think it becomes very interesting, is that service providers have to think about new strategies around their fixed network. Because as I was mentioning earlier on, service providers are going to play a huge part in rolling out these services to different points in the network and supporting governments. But one thing that AI needs is lots of bandwidth, and it needs to be low latency, and also adaptable to change. Because the one thing about the data being consumed in AI is very disparate, it's very different. If you think about creating a new song in your mind, it could be based on a feeling, a smell, or a taste. Those things I've just described are three very different senses. Now we're asking a machine, a piece of metal, to take those different senses and make something meaningful of it that we can consume as humans. And so that means the network and the fixed network will have to be adaptable to change to those different needs as we put different models onto that network. So I just wanted to go into a little bit more detail about how we see the compute being built. And this is important. So this is how it looks in the data center. But as we push AI closer to the edge, these are the kind of compute instances that will have to be pushed to the edge to be able to enable digital services and AI services as they're required to get closer to the user or closer to the home and just pushed further into the network. And so on the left-hand side, you have this new generative AI backend. So this is a network that does all the number crunching. And then once it's actually worked on a large language model, it passes it to a traditional front-end network on the right-hand side. So this is CPU-based. And it's the blue box on the right-hand side that communicates with the outside world. The back-end network in green is kind of a closed shop, if you will. All requests come in through that cloud I've drawn. The front end decides whether it can compute or not, and then passes it to the back end. If we look at this network, it's very short distances, 5 to 500 meters, really running speeds of 800 gig, 400 gig, and 1.6 terabytes as well. And so that represents the fact that we have these nodes, these compute servers very, very closely together. So that's that's within the building, within the campus. Now, what I've done is I've grayed out that box below, and there's another important part to this whole network that I was mentioning. If you remember, I said that we have to get these services out into the network, and that's performed by a part of the network called the Data Center Interconnect, or the DCI. And that's what actually transmits this data out to different central offices, different cell sites, different nodes in the network, okay? And that has much greater distances to cover, 5 to 10 kilometers, use a different type of technology, CWDM, DWDM, or the new 400G ZR standard. So it looks a little bit different, but it's extremely important. Because at the end of the day, once we put everything into that node, all that computing, all that GPU, all that AI capability, if you don't have sufficient bandwidth and low latency networks to get out from your central office or from your node point, then all that's for nothing. So I'm encouraging you to look at everything that's in the gray box and think about how that's generating more and more demand and more data and pushing that out onto the data center interconnect. It's very important. A higher number of fibers have to be managed and managed from the central office out into the ducting, and you have to think about the ducting as well. How is that going to manage all the fiber cores we're now talking about to transmit these data levels? There's a challenge in my industry, in the data center side. There's potentially an opportunity for a number of people in this room and this industry at large. The one big challenge we have on the data center side is power. So I mentioned to you that AI is driven by GPUs, which consume a lot of power, sometimes have to be water cooled because we're running out of cooling capacity with air. They're generating a lot of bandwidth. So what you're finding is, so for example, in Amsterdam, there was a moratorium around building data centers because of the amount of power that was being consumed, the amount of energy and land that was being consumed. So what we're seeing is data center providers pushing their infrastructure across campuses and across different locations in cities or across different cities. And so you can see on the left-hand side here, I'm talking about a data center owner needing 150 megawatts, which isn't a huge amount of power these days in the data center business. But the site they're at only has 50 megawatts available. So now that organization has to push out their compute load to other locations in the network. So they may build their own ducts, but more likely than not, they'll be going to the service provider organizations who already have ducting in the ground and maybe leasing that ducting from those organizations. Or maybe they need to get access to dark fibers. And again, service providers probably have an abundance of dark fibers in the ground that can be lit up and provided as a business opportunity for many of the data centers. So again, I'm talking about how the fixed network, we may have thought about that in certain terms previously, but now it has a part to play in this whole industry and needs to be dynamic to support it. If you look at this graph here, I think it's very interesting. If you move from the right-hand side to the left-hand side, we're moving from the core of the data network right down to the subscriber. And if you look at the very bottom line, I'm describing the type of applications that run on those networks, but I've placed them with respect to their latency. So, for example, if you look at robotics or if you look at gaming, the response time has to be within 10 milliseconds, and the speed of light is kind of a fixed parameter. So you have to put your compute load, your AI load, close to where the end device is. So what I'm demonstrating here is that actually there are many locations throughout the network where you will have to provision GPUs and CPUs to be able to provide the kind of performance that's required by those end devices. And you can see up there in the right-hand corner, I've got that color bar showing the data center interconnect again. So again, it's very important that you provision, you have the right ODFs and the right fiber in place or the right capacity in place to be able to support those networks as they're rolled out to the central office, to the radio access network, and then thinking about the fiber to the home part of it as well, coming towards the customer premises. The way we think about that network is going to have to change. And so I keep mentioning, actually, I'm very conscious I keep mentioning that we have to think differently about those endpoints. And you can see some data points I've got here that we're looking at different immersive experiences. So, for example, I'm mentioning AI-enabled VR and AR is using up to 65 gigabits of video data, coming from a stadium. 8K UHD uncompressed images. We're all used to seeing better and better quality pictures from the Olympics and from football games. Those broadcasters will be using uncompressed video and probably transmitting that to a local point somewhere where they can actually modify the images that they're seeing before being broadcast out onto the public network. And then finally as well, at the bottom there, the 50-50 figure. If you look at a fiber to the home network previously, it's probably been very much one-way transmission, so it's gone from the central office down to the user. And one thing that I mentioned right at the beginning of my speech is that AI is different. The data points are all different. Okay, we talked about a sense, we talked about a smell, and then we're asking a machine to bring those senses together and make something meaningful. So where AI is being generated, suddenly the workload is not symmetric, it's asymmetric. Okay? And then just finally, just want to leave you with these couple of points here about generative AI as being different. As an organization, as an industry, we'll benefit from AI. And then finally, think about your planning in your network as well, because these new applications are coming along. Thank you very much.
Thank you, Alistair, for giving your insights and your outlook on how to implement AI in networks. Let me continue with the third topic, which is titled Digital Intelligence Accelerates All Optical Network Development, and it will be presented by Hans Neff. Hans has more than 30 years of experience on telco and IT, working as consultant and integrator for operators and vendors end-to-end, leading Tier 1 projects all over the world based on a broad technical multi-vendor and international education. This laid the ground for joining ZTE in 2014, where he is reporting to the board since 2016, a member of the CTO group of ZTE since 2017, and the senior director of the CTO group since 2018, continuing gaining experience with every new realization and project being involved. So, Hans, please take the stage.
Thanks for the great introduction. Thanks for the audience. Thanks. It's an honor to stand in front of you because you are the FTTH family. You are hosting customers, you are building networks, you are maintaining networks, and you're doing this for some years right now. The good news is we all will do this for the next years too. Depending on where you are, depending on what you do, you stand in front of very, very different hurdles and very, very different challenges. But all of those challenges can be faced and overcome. There are various initiatives, Gigabit Society, Digital Compass, Digital Decade policy programs, who initialize the move of renewal. And various countries, regions have started approaches to go forward and, to be honest, to build further, innovate further, and give better connectivity to home, enterprises, and industry. There is a big growth still there. For sure, you have countries with 90% FTTH penetration and high population reach, but that's not the standard. Now, if you build a network, if you maintain a network, to be frank and honest, it costs money. And this money is not equally distributed. So you have money to be invested for constructions, you have money to be invested for components, for fibers, for OTNs, for ONUs. And the bad news is, as more difficult it is, as longer it takes your ROI back, as lower your market penetration is. I think that's nothing rocket science. You don't need AI that for. You have several things which contribute to the complexity. Differential knowledge levels, various regulatory or regional requirements, risk of errors, increased fiber density, overbuild. There's a lot of things which might be difficult. And AI comes. But now, coming to the low point of the presentation, AI is not the solution for everything. Don't believe it comes and solves whatever is there, but it can help. And let's dig a little bit into that, what AI could do to simplify processes, to improve sustainability, or even customer perception. At the end, every FTTH networks deals with the aspect what to do before construction, what to do during construction, and being honest, what to do after construction. Because this whole life cycle is the thing we all serve to. We all provide components, maintenance, service. And from starting with intelligent surveys, integrated platform programs, paperless communication, to fast deployments, easy deployments, to good planning, end-to-end visualization, documentation, and better quality service. This all can be benefiting from AI. I mentioned before, AI should not be used for anything. My colleague already mentioned AI costs power, AI costs money, and such as it's not for free. Don't use it for repetitive things. Use it for things where a value is behind and it saves you money. If we take a look before construction, a lot of construction companies still work with papers. So they get their paper block in the morning, they drive out to their troops, the troops get a per phone or verbal discussion. The survey is done in a kind of car driving way, not automated. So you have their ways to improve. I don't say this is a recipe for everybody and everybody does just paperwork on that. But the first thing is, do it as automated as possible. That's not AI, that's common sense. So as digital as you can do it, with an app on the phone to make an easy documentation of the infrastructure, to make an easy site survey, to exchange easy information, to in the digging process go there, make a picture, say the ground is different than I expected, makes an easy change in the efficiency of the work. To have then behind an AI design tool which reacts on various pricing points of the digging, because sorry to say, digging, drilling, rocketing has different prices. How to do this efficient, how to reach each and every household in the best way and in the best common way, cheapest possible, is the aim of all of us. And having an AI design who takes all of the, or most of the, all is a very big word, sorry, most of the surrounding environment into account in planning helps to make it as precise as possible. Out of this, you get an automated output, which is distributed to all persons relevant for the building. So having an automated data collection, an automated model training, an automated calculation, and an automated output is a very, very big step forward. If you talk about during construction, you have there not one drop, hopefully. You build it in a bigger scope, in a bigger scale. You have more than one polygon you send people to, you plan it end to end, you have to go for administrative work to close down streets in a very processed way. So you have to have a process set which helps you to deal with things. You have the problem that everybody of us has to build cheap. And this is not degrading people or something else, but everybody tries to go for cheaper resources. So you try to have intelligence somewhere helping to have less skilled persons doing the job, making it cheaper. You have tools that those people dig where they should to dig, do what they have to do, connect how they have to do it in the quality you need. You would like to go for splicing free because every splicing costs you 20 minutes. You need a guy who can do it and who can do it not with 1.5 dB and biting the isolation down with the teeth. And you should have something which helps you to go, in a way, we go for pre-connectorized or pre-documented services to make it easier. So to do that, it's good to visualize end-to-end the whole process you want to build. It's good to have an insight in the geographic topology, in your trenching, in your digging, in your tubing, in your DP, in your CP topology. It's good to see where you have to splice, where you do it, and coordinate this with an all-overview service distributed on apps to the teams where they can give you feedback and responses. And do this in an automated way. One set which is important during deploying, use the right products. I don't want to now make a commercial session for my company, but at the end, you have various sizes of various products who fit to certain requirements. If you want to build something outdoor, use it. If you want to have centralized OLTs, do it. If you want to mix it with remote OLTs to come closer to the customer and have a cheaper deployment, do it. If you want to replace HFC, do it, but do it with the right equipment, with the right size, with the right configuration, with the right design. Try to go for power saving, latest technology to save energy, and for sure, I think that's a common sense, try to go for a full flexible air-blown ODN structure, allowing you to have easiest blowing in, longest distance, proven technology. To go to rural coverage, because to be honest, the cities are mostly covered by us. Rental fleet deployment, rapid user acquisition by doing that, and think about coexisting with the mobile stations. They're not the enemies. So you can provide fiber to the mast, you can interact with them, you can co-use the sites, you can co-use the power, use the efficiency. After construction, congratulations, you have a network. But you should be able to visualize the network, to understand what is going on in it, the quality of experience, the connectivity, how is even the Wi-Fi behind? So to be honest, 90% of the complaints of customers are not about your optical infrastructure. It's about the last 10 meters. How is your service environment? How can a customer who complains get a fast response? How can you visualize your whole ODN network in case of a failure that you can directly interact, find the point of occurrence, and repair it? And at the end, it's a tool set which allows you end-to-end to visualize from the set-top box at home, from the Wi-Fi, from your ONT, OLT, IP, DWDM, to the internet connection point. How is the interface structure? How is the communication structure? How is your network? Where is your splicing point? Which quality has the line in one set? So basically that you have an overview end-to-end. That helps you to analyze problems easier, to make an intelligent way for diagnosis, to make a root cause analysis who helps you fast recover issues. You receive alarms, you have their dedicated platform who does an alarm analysis and pre-provides expert resources, pre-filtered, sorry. So you get a root cause analysis sets, you get suggestions on improvement, you get a dedicated set where a cable is affected, cable aging prognosis. You have there also a set to show which ONT, which SDP is influenced by a deviation. So it gives you OLT diagnosis, fiber, ONU, and service diagnosis in one shot. With this, you have to have a baseline. The baseline for everything, automation, AI, is data. Data means you collect out of the network what you can get. OTDR measurements, data collections, logistics, data parameters, trend sets, digging parameters, splicing data, optical path parameters, everything you can get. You have an AI parameter set behind, so an analysis, as we have seen before, training sets, inference sets, generative AI, who give you an insight on what is going on with that parameters. So you get their data on dedicated identification passes like denoising, transformation, feature analysis of certain sets, and you have them behind an AI-based analyzation tree, allowing you to have a pre-analyze and an indication, what is it? Is it broken? Is the light power changed? Is it diversed? Is it banded? Just age, and you get some pre-warnings. What will happen soon? Because you have long-term statistics, you know the energy consumption of the fan raises, might be the filter full. So very simple things, but you get notifications out of this which give you pre-warnings, give you presets, and help you to maintain the service easier. New technologies are also needed to support basically the network optimization. And there are new technologies available which help you to document your network automatically, which help you to integrate the services automatically, and which help you to increase the resource accuracy, the active dump resource usage, and the fault elimination easily. So having an insight to your network on a quality level. This all together goes down on 3 main points: intelligent platforms, comprehensive solutions, and, to be honest, a local win-win collaboration, which are based on interoperable standards, APIs, an integrated platform, and an AI algorithm. I hope it was of a little interest. Thanks for your patience. Wish you a great day. Thanks a lot.
So thank you, Hans, for your views on the road to a fully intelligent optical era. The fourth and final topic is about 50 gig PON and the leap towards a sustainable intelligence network infrastructure, presented by Christoph Glingener. Christoph has become the Atran CTO in January 23, following the company's merger with AFA. Christoph assumes the responsibility for Atran's global R&D, technology and strategy and product activities. Previously, he was ADVA's CTO and led the company's product management and advanced technology teams. Christoph's role at Atran builds on a long and successful industry career with experience gained in both academic and corporate roles. Christoph, the stage is yours.
Thank you, Carl. And I think by now it's afternoon. Good afternoon, everyone. I think we're running a little bit late, so I'm trying to be faster than I initially was about to be. What I'm going to do is take this back a little bit more to technology, fiber to the premise, fiber to the home technology, but then also go through some of the topics we already saw, maybe provide a little bit of a different perspective to those, and hopefully lead us quickly into the discussion we want to have. So I think I don't need to explain who we are. We're at the FTTH conference. If you don't know, you're probably at the wrong conference. But what we do is anything from in-home access, fiber to the premise technology, back into the network, optical. You just heard about the ATFA-Atran combination, also DCI. Alistair talked about DCI, hopefully a big successful future in DCI with the all AI build-outs everywhere. That's what we do. Now, thinking about the hot topics and the technology topics, and as said, I want to get you a little bit back to FTTP, FTTH technology. If you look at the bottom of what you see here, speeds and feeds, subscriber speeds moving to 10 gig and beyond, not just residential subscribers, could be mobile backhaul, could be business services, could be. If you then go into access speed, obviously scaling beyond 10 gig. I'm going to get to the 50 GPON in a second. If you look at that graph from Del Oro there, of course, we all agree that it will be 10 gig for some time to come. The majority of the business in the fiber to the premise space. But you see this blue one on top there, the next thing, which is the 50 GPON coming up. And then, of course, if you go into the network, moving from 100 gigs to 400 gigs, and so on and so on. Lots of topics. We already heard about sustainability. We heard about AI. I call it here data-driven intelligence and automation. Disaggregation, modular platforms, different way of building networks, changing how we do them, maybe centralizing them, maybe AI fuels a different network infrastructure we're looking at. Some other topics we haven't talked about yet, but I'm going to come back to them. Before I do that, we call it the next great expedition, 50 GPON. So what comes next? And we can talk about drivers and speeds going up like I just did, whether it's residential or enterprise or it's mobile backhaul. Important is the coexistence with GPON and XGS-PON, so with 1 gig and 10 gig. And also important is for us, obviously, the first products coming out. I think we want a price on that 50G product here at this conference. If you haven't seen it, go to booth number PO2, you can see it live there. So where are we as an industry with all of this? First products just coming out, just being announced. You remember the curve we just saw from Del Oro. Of course, it's some way to go in this. Probably 1 to 2 years till we see this in volume mass deployments, more like 3 years. Some ecosystem which needs to build, some cost which needs to come down, optics and so on. and so on. But it's starting. I'm probably seeing first initial deployments in 26, I would say, with this one, and then slowly going into more volume, as per the curve you have just seen. I want to talk a little bit about sustainability. Theo gave you a great overview on sustainability, but I want to move a level up. So what you see here on the left-hand side is the global CO2 footprint of the ICT community going up over time. Now, there are always some people arguing, well, remember the pandemic, remote working, we all stay at home, so we don't move, wonderful. An overall reduced carbon footprint because we sit at home and don't drive. So that's the green curve going down. However, the emissions keep going up. The energy consumption keeps going up. Alistair talked about what we do in AI with GPU and on. You see, I put a red arrow here. That really pushes it up, the energy consumption in here. Now, we see a lot, we all have targets, and as an industry, we do a lot. Net zero targets, SBTI targets, the different scopes, and so on and so on. However, let me be a little bit more pessimistic here. Well, if you take all the greenwashing out, I think it keeps going up. So what can we do? Yes, we can use renewable energy. In some countries, we can claim we have nuclear energy. It's all green, no problem. But it keeps going up. Are we doing a lot as an industry? Yes, we do. The energy efficiency keeps going up. This is a very simple rule, sort of derived from anything we saw in the past decades. We get about 5-fold better over a decade in energy efficiency in what we do. Whether you look at optical interfaces, transmissions, next generations, ASICs designs, and so on. That is when you relate it to the same speeds and feeds. Like if you look at the gigabit per second, how much energy do you need to provide that? Whether it's fiber to the home or whether it's transport, we get 5-fold better, roughly. However, the bandwidth growth is much faster. So we keep going up in energy usage. Now, what can we do? Of course, we can use renewable energy, as I said. We can try to be even better in this energy efficiency. We can recycle, better circular economy processes, and so on. I'm a little bit less pessimistic, or a little bit more pessimistic. It will keep going up, whatever we do. So AI, we heard a lot about AI, so I can keep this really short. I just want to make some points. Yes, it will change the networks. Maybe it will not change the speed and feeds in fiber to the premise technology that much. It will change how we run the network. And I put some interesting points down here, which I saw. For example, Deutsche Telekom said, I think it was an earnings call in October last year, they expect a 20 to 30% efficiency improvement in running the network, customer interaction, some of the points Alistair talked about, 20 to 30% efficiency. Now also here I'm playing a little bit devil's advocate. Let's see what that really is. Is that less people, being faster, being more efficient? There's definitely a lot in there. And then there's an internal example, how we build those products we do. So being smarter in how you design products, whether it's hardware, software development, how you test, how you do things, we see about 10 to 20%. We can get even better in that. So that's totally different area than the networks themselves and how it changes the networks. And then maybe the last one, as said, I want to be fast. There's something we didn't talk about at all, which keeps us all busy lately. Whether it's the geopolitical evolution, it's tariffs, I don't know how, well, I shouldn't get political here at all, but I switched on the TV last night before going to bed, saw something and switched it off and slept. Well, that's how you feel these days, because things are very dynamically changing, which influences us. The way we do things, where we build things, how we do things, how we build things, what customers are asking us where they want it from, and so on and so on. It changes some things. Alistair alluded to it a little bit, but there's something happening there, not to talk about government funding. And when I talk about the increasing amount of policies, I think in the area of sustainability, we have a hard time following those. What the EU produces as new regulations and policies, just to go after them. That's maybe a little bit negative. But one thing I do see we didn't talk about at all is a much bigger push for less vulnerability, security, availability of networks, whether that is assurance, whether that is high availability in terms of putting redundancy in, whether that is encryption, monitoring, all of it. There will be more coming going forward. And with that, I hope I gained some time. Thank you.
Thank you very much, Christoph, for your view on the future. I will start now with the panel session, and I will direct myself to you after the first question. So if there are questions coming up, I will open the floor after the first question. Good, so there we go. And I have a first question, and I would like to come to talk about the decarbonization and the importance about it, as Theo highlighted in his opening statement. My question to you is, how can the FTTH industry players be sure that they are using the right sustainable solutions for their project?
That's a very good question, Carl. I have to admit that there is no multiple way to do that. The FTTH stakeholders must ensure that they engage with the supply chain players that have the full control on their life cycle analysis of the products that they are offering to the industry. It's the only way to make sure that by getting certified documentation on what they are using for their infrastructure will be guaranteed, right? So at NetSeed, for instance, we do have eco-design working stream, part of our ESG strategy at the group level. I'm heading that work stream. And today we are able to provide for any of the products that we're offering to the industry LCA documentation. So I think that's for, in my opinion, the only approach.
Okay. Hans, do you want to add something to this?
I think for operators it is important to understand their end-to-end supply chain. FTTH Council has launched, not long time ago, by the Sustainability Committee, an eco platform. And the eco platform allows in a very, very easy way to say, where is my sourcing from? What am I contributing to the CO2 emissions? And how can I improve by comparing other inputs? So it's neutralized, don't get me wrong, there is no business secret shared. But at the end, you can see where is the most CO2 economic sourcing from. So it's now basically, I think, an easy way for everybody who wants to contribute there to see directly how good he is. Let's do a little challenging, and to see how he can improve. So just my 2 cents on that.
Okay, thank you.
Can I maybe add to that? I think one thing we probably need to put more attention on is the in-home piece. I see some of our customers just looking at the OLTPs and so on, but then the real driver is what's happening with ONTs, RGs, all that stuff. What do you do with them if they fail, or if a new Wi-Fi 7 comes, Wi-Fi 6 is done, you just bin it? And then comes another box. So that's a very interesting and big piece of the whole equation.
Mm-hmm. Okay, thank you. As promised, I'm turning to the room. I cannot see you very well, so put up your hands well above your heads. Questions? If not, I have a long list of questions, but I prefer yours. Okay, don't want to go. So,
don't be shy.
I would like to go to AI. That has been one of the topics that has been, very present also in this conference. I think actually, if you have to have one keywords of the conferences going on, probably AI is the word. A question I would like to address to Alistair, but the others are free to react on this. Are network transformation now happening too fast because of AI? Can you give your insight on some speeds that you see there?
Yeah, thanks for the question. I've been in the industry working for switching manufacturers, semiconductor manufacturers, passive infrastructure manufacturers for 25, 30 years, and I've never seen a change like I'm seeing in the last 1 or 2 years driven by AI. Many of the conversations that I would be having in the marketplace would be around upgrading your equipment every sort of 5 to 6 years, probably driven as much by technology change but almost by accounting principles, because that seemed to be the rate that the finance department would be amortizing equipment, and once they'd amortized it, then they could get a new budget to install more equipment. What we're seeing today is that, you know, we make an estimate as the industry about the data rates and the deployments that we're seeing, and it's almost out of date instantly. And I'll give you an example. So NVIDIA, they had their GTC conference last week, and they've gone from changing their GPUs or updating their GPUs to be more powerful with higher data rates from every 2 years to 1 year to every 6 months. And that rate of change is huge. And with every iteration of that GPU, we see a new speed coming out. So, you know, 400 gig 2 years ago was unheard of in my type of world, in my industry. And then it's 800 gig is becoming normal. Now we're looking at 1.6 terabytes and maybe different techniques by which to transmit the data optically as well. So the rate of change is absolutely dramatic, and it's almost out of date as you talk about it.
Okay, good.
I think, so I agree fully, but I think we have to differentiate between various AIs, One aspect is the OTT AI. So everybody uses ChatGPT, whatever, to seek, search, find, text. So basically using AI as transport media. It includes a little bit AI on the terminals. So like you say, how to refurbish it. So what is now if a new generation comes out with a new GPU allowing you to do locally something else? So it has an impact, which is a big impact on sustainability on one effect and renewal processes. The second one is kind of the operational AI. So this is what I touched, where you say how to make the process of network better, easier, faster, whatever. There is also a big change which is driving the digitalization of this industry mainly. And then you have this network AI where you say, okay, my OLT does energy consumption better, and you have there some change and improvement. I think personally, in all aspects, except the direct end customer aspect, AI has a pure TCO game. If AI brings me a benefit, I do it. For the direct customer interaction, so if he gets a new iPhone or a new Samsung phone or a new whatever phone or a new terminal which can do something better and he wants it, he doesn't care what it costs, Otherwise, nobody would spend 2,500 euros for a phone. That's the very honest thing. So it's two sides of a coin. One is customer-driven by interest, very fast, and the other one is pure TCO-driven, so even AI is there. If it doesn't bring the benefit, what was one of my sentences, don't use it for everything, you will not go for it. Just my sentence.
Okay, good. Turn it again. Just raise your hands and you can fire your question. No. Let us continue on that. AI, not maybe from a speed point, but from a game changer in network automation. And especially how digital intelligence accelerates the development and the operations of the network. So a short question to you then. Can you share real-world examples of what you see, Hans?
Mm-hmm. So basically everybody wants to build cheaper. Everybody wants to maintain cheaper, faster, more sustainable. What we can see right now is automatic planning tools. So at the moment, classically, you do QGIS, you do some basic stuff, you enter your points, you have manual planners. And we've seen lately, the last 18 months to 24 months, more and more automated planning tools, automated coordination tools, multi-tenant structured automations for interaction with the troops, with the diggers, with the services to make a digital move. So basically in deployments in Austria, in Germany, in Hungary, in Croatia, where we see that running, the use of such tools comes more and more into force. And you see there a value behind that. You see the digitalization, and I would like to expand the terms. It's not just AI. It's digitalization, it's automation, it's finally topped up with an AI, helps basically to make processes faster, easier to deploy in the planning, in the audits, in the complete administrative story, and in the coordination of the troops, people, and the digging process. So we save there, at the moment, more than 30% of costs and time. What is I think, a sustainable value.
Okay, thank you. Yeah, Alistair,
Sorry.
short reaction.
Just one thing I'd like to add to that. All very important points. And yes, there are new techniques, there's new software, there's new tools that are coming along. But the restriction in the network sometimes is the physical cabling, the ductwork. Once that's in the ground, it's stuck. So my message is you've got to plan for the future. You've got to think about those next great things coming along, because otherwise you can't use those tools. They're going to be absolutely limited.
True. Agree.
True, please.
If I can add to
Christoph.
that, this is a very good topic. I think the secret is really in getting all the data to feed the engines.
Yes.
Right? So if I look at a real-world example of, let me say, fiber to the premise, if I can see anything which is going on in-home, the fiber in between, the OLT, the services running over it, feed something with it, then I can do real nice stuff. And some customers are doing this, but that's not an easy task. First of all, you need to be set up to get all that data, to do something with it. But that's a trick.
Yes.
Get all the data and then go from there.
Agree.
Okay, I would like, again, looking at you, Mike.
Don't be shy.
Yeah, I have a long list. We can hear for a long time. We are not going away before the question of the audience is asked. So save your lunches, I would say. Good. Let's go to speed. What are the key steps to 50 gig into volume deployment? Because, you gave us a lot of taste, but then, I had a feeling, okay, so tell me, Christoph, how are you going to take it into the real life?
I think like with every technology step you do, it is at the end of the day about cost. So it needs to be cost competitive. Not everybody might need every speed. Yes, there are services driving it. If you look at mobile backhaul or enterprise services, you might have different cost targets than looking at residential services. As you saw, 10 gig will be the bulk of the business going forward. If we get into comparable ranges of 10 gig, I think it's a no-brainer. But that needs some steps. First of all, of an ecosystem of whatever ONTs, RGs, everything coming with it, and the OLTs. It also needs the optics to come down.
Is that the critical step for things to happen, the optics then?
I think the bulk of the cost is in the optics, really. It's the optics, and at the end of the day, it's volume. So if you want to, it's a little bit of a chicken and egg problem, like with 10 gig, like with every technology. That's why I can see it coming. I can see it for higher speed services, different than residential services. For residential services, I think we have 1 to 2 years to go, and the chicken and egg one we need to solve is get the volumes up.
Okay, we have more kit vendors here, so Hans, Hans,
You want
go
to?
ahead.
Okay.
Yeah, go ahead.
50 GPON is faster. I think we all agree. It's not the value. Sorry. We can do the same as you do with the questions in the audience. Who needs 50 GPON? I think it's the same reaction. The thing is now, 50 GPON is about speed is one aspect. The optics, the price is one driver to deploy it massively, and I fully agree with the ecosystem. The understanding what additional value 50 GPON gives you is also helpful, and specifically the understanding on the operator side and the end customer side. 50 GPON helps you to open a new business. And what means for new business is FTDM. It's an old business. But with 5G, 10Gs was no longer sustainable or efficient. You couldn't transport clock, and you didn't have the speed. So 50 GPON allows you basically to come back to FTDM because you have a straight-on-one capability on transport. Clocking is one of the big benefits which you can do with 50 GPON. And you have the speed to connect a 5G site with 3.5 gigahertz or even millimeter wave. New effect. Second thing is, the term slicing is overused. I apologize, but I think it fits best. You can assign certain bandwidth to certain services / users. You have no longer a fully shared medium. So you have one enterprise on a splitter, give him 10 GS symmetrical. The rest of the 50 GPON you can share. So you can steer traffic. And last one is latency. Okay, if somebody pays you for latency, we are back on 2B. Let's see.
Okay, I would like, Alistair, you want to react shortly on this?
No, I'm fine.
Okay, good. Dan, please.
Maybe just a quick one to conclude because I think that we are running out of time. With these new technologies that are coming, the 50 gig, maybe tomorrow 100 gig, the 6th generation of the mobile network also is coming. We have also the emerging smart cities with more applications such as connected driving, for instance. So all of these new technologies will require sustainable fiber optic network, and it's also today that we need to think to select the right solution, eco-friendly solution if possible, for the future.
Okay, thank you. Well, ending with sustainability is good, but nevertheless, I'm just at time 0, but I'll give you a chance to ask a question to the audience still. So one final question. You don't seem that hungry, you know?
You're there?
Okay, if not, then I would like to thank my speakers, my 4 experts. Thank you very much for being here, listening to us. Thank you.